Hey everyone, my name is Ginny McIntyre. I am usually the one behind the camera, but today I am up at the whiteboard ready to practice some permutations and combinations. So first of all, what is the difference between a permutation and a combination? Well, for permutations, order matters. But for combinations, order does not matter. All right, so for permutation, we can do some conceptual examples. So a combination lock, as you might know, should actually be called a permutation lock because order does in fact matter. So that's a big one here. And then we also have selecting individuals for a team by position would be a permutation because order matters. So if you have like a first, second, third player. So for a combination, for example, we would have, if we're picking 3 finalists, we don't have a first, second, or third. We just have 3 finalists. All right, and then another example of a combination would be selecting children to be members of a class. So let's start off with an example. All right, so we have, this is Eleanor, and Eleanor is wanting to order a pizza, and she has 10 toppings to choose from, okay? So we have 10 toppings. But there's a limit on how many toppings she's allowed to order. So we are going to say she's picking from 4 choices. So, is order gonna matter on that one? Is Eleanor gonna have pepperoni, pepperoni, olives, pepperoni? And that's gonna be different from pepperoni, olives, pepperoni, pepperoni. No, it's not. So this would therefore be a combination problem. So how are we going to do this, you ask? Well, this is where our calculator comes in handy. So we have C because it is a combination. So we have 10 because we have 10 toppings to choose from and we need 4 choices, so 4. Therefore, 10C4. And then we're going to plug this into our calculator. And when we plug that in, we end up getting 715. So there's 715 different combinations of the 4 toppings that Eleanor could choose for her pizza. So I hope she enjoys that pizza because she's got 715 different ways to enjoy it.
But what about for a password? Would order matter?
Yes, Eleanor, that is a fantastic question. So let's start with passwords, meaning permutations. So if we want to do 1, 2, 3, 4, 5, 6, that could be our password, albeit not a very strong one. But we could also do 6, 5, 3, 4, 1, 2. And there we have 2 different passwords, meaning order does in fact matter. All right, so let's say we require a 7-digit password. So we need a 7-digit password, and that can be a mixture of both letters and numbers. So how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0. So 10. So we have 10 numbers to choose from. And how many letters do we have to choose from? Well, of course, there are 26 letters of the alphabet. 26 letters. Oh, but Ginny, we have too much to choose from. We have numbers and letters. Whatever shall we do? I have an idea. Add them. And that gets us 36 numerical / alphabetical options to choose from. All right, so we have 7-digit password and we have 36 options that we can choose from. That's not our final answer though. All right, so since this is a permutation as previously stated, we're going to start with the P function on our calculator. And we have 7 choose 36. We have 7 permutation 36. So we're going to do 7, 36. So that gets us quite the wonderful number of around 4 million. So we'll just abbreviate that as 4 mil. All right, so that's our final answer. Now let's do one with class sizes. So let's say we have 15 men and 12 women, and we want to choose ways that 2 men and 2 women can be put into groups of 4. So we want to make groups of 4 consisting of 2 men and 2 women. How would we do this? We have 2 different variables, and we actually have to make both of those variables into the same group. So what we're actually going to do, since this is a multi-step problem, is we're going to break it up. So we know that we are going to choose 2 men from the 15 men and 2 women from the 12 women. So we are going to do 15 choose 2, which gets us 105. Then we are going to do 12 choose 2, which gets us 66. So what are we going to do with those numbers? We are going to multiply them because we have the two different variables here. So therefore, we must multiply. That will get us a total answer of 6,930. So again, we have 15 men, 12 women, and we are trying to make groups of 2 women and 2 men. And that gives us over 6,000, almost 7,000 options to choose from. All right, so next example, let's do one that hits close to home, music, specifically wind ensemble. So Dr. Kennedy's wind ensemble is planning to play 5 pieces of music. So with these 5 pieces of music, he already knows which ones he wants, but he wants to figure out which order he will play them in. So let's ask ourselves the question. Is this going to be a permutation or a combination? Well, if you said permutation, you would be right, because order does in fact matter. So we have our program. We're going to have 1, 2, 3, 4, 5. And that's our program. How many different ways can we do that? And you're thinking to yourself, Ginny, we don't have a second variable. All I have been given is 5. Are we sure about that? Let's think. We have 5 pieces. But how many options do we have to arrange these pieces of music? 5. So therefore, our equation will be 5p5. And 5p5 gets us 120. So Dr. Kennedy and the wind ensemble have 120 different ways to arrange their pieces of music. So a lot of creativity on his part. Let's break down these formulas. So first off, we're going to do our permutation formula, which is going to equal n factorial, which looks like an exclamation point to all of y'all. And that's going to be n factorial over n minus r, in parentheses, factorial. So that is our formula, which it depends on if your teacher lets you use a calculator or not. Are you going to be able to use that formula, or are you going to do it in your calculator? And then for the combination formula, we are going to have n factorial. So that's easy to just remember, same numerator. And then with this one, what is different is we are going to have r factorial times n minus r factorial again. So that is our combination formula. So let's say we have something where we cannot repeat any letters or numbers. So we are being asked, how many times can we arrange the different letters of crystal? So we have 1, 2, 3, 4, 5, 6, 7. We have 7 different letters in the word crystal. So we're going to do 7. But, are we going to do a permutation or combination? Does order matter? Yes. So what is a permutation? But since we cannot repeat any of the letters, we will be doing just a plain old 7 factorial. So like a 7 with an exclamation point on it. And 7 factorial gets us 5,040. So we have 5,040 different ways to order crystal. All right, last equation. Let's say we have a table and we have 3 people that are sitting at it. So we have a chair here, here, and here. And then we don't have enough friends to have someone there. We only have 3 people for this problem. So what are we gonna do? We have an A, B, and C person. So how many different ways do we have? We know that we have 3 people, but you cannot repeat them. So we're going to do 3 factorial, which gets us 6, because that's an easy one you can do in your head. 3 times 2 equals 6, times 1 still equals 6. That gets us 6. So we have 6 ways for the people to sit at said table. Anyways, that is enough, and I will see you all in the next video. Don't forget to like, subscribe, and comment. And as always, do not hesitate to book a Mu Alpha Theta session online at hfamualphatheta.com.